Okay, I have a lot to cover, so I'm going to start. Yeah, I know people are probably still rolling in, but unless you've worked with data server products in the past, anybody? Yay! You may not know who I am. I used to do architecture for the data server products. I work in the core product group now and have been working on security stuff for about a year or two here and there. And so I'm going to talk about cloud application security today. You can see from the subtitle, there's going to be a lot of discussion about OAuth 2 and OpenID Connect in this discussion. It's relevant to this topic of cloud application security. Are there a lot of people with OAuth 2, OIDC experience, knowledge? A little bit? A little bit. Okay, a little bit or a lot? Anyone expert? Okay. Okay, because I have a lot of content. I want to be very specific, and I don't normally do this sort of lecture style, but I'm going to do a lecture style today because I have a lot of content I want to make sure I can provide. It's not really hands-on, it's more conceptual, what I want to discuss. So let's move on. Agenda: OpenEdge in the cloud, OpenEdge cloud application security, OAuth and OpenID Connect contexts, and then OpenEdge token security requirements. So OpenEdge in the cloud, there's lots of cloud configurations possible. Most cloud configurations, depending upon whether you do SaaS, PaaS, IaaS, public, private, they're all generally tend to be hybrid in nature. The IT pros rank security as both the primary benefit and the biggest challenge of cloud computing. Cloud infrastructure sometimes offers better layering, more hardened systems, better firewall protections, advanced heuristics, continuous infrastructure upgrades, etc. Typically, they are advantages that are useful, but the flip side is that the hacker payoff is higher. There's more data to collect. There's more to gain from their taking over your infrastructure and gaining access to data. So if you look at the top 7 cloud security breaches in the last couple of years, ranking at the top of the list is Microsoft had an incorrect configuration in one of their authorization protocols. LinkedIn had a dictionary attack on pre-calculated unsalted hash values that rendered passwords. Apple iCloud had a policy tolerance for weak passwords. And then there was, the last one was, what's it called? I'm blanking on the name. Yahoo, thank you. Just Yahoo. 3 billion users potentially breached. It was started off as just a spear phishing attack by Russian hackers. They were able to get into the database. They downloaded the database later on through a back door. And then they were able to take advantage of some nonces that were set on email records, email recovery records that were were able to take those and turn those into generate tokens, access tokens out of them. So what that tells us is that oh God, what is going on now? Okay. What that tells us is that a lot of the things that are happening in cloud security are actually things that are happening, on a regular basis in regular environments. The top cloud security threats, as we look at them, are things like insecure interfaces for APIs, abuse of cloud computing, shared technologies, loss of data. They're all data integrity and data authorization issues. They're not so different from other environments. But there are some things related to this that we need to talk about. So OpenEdge is likely one of the many layers provided in your software stack. If OpenEdge plays a dominant role in your enterprise, there's increasing pressure for you to integrate it with other software vendors, right? So that pressure only grows over time. Your range of offerings and capabilities, out in the marketplace tend to proliferate, which just puts more pressure on you. So these difficulties create, cohesion in your security strategy. Your compliance demands begin to morph. They build upon one another. You've got looming threats. You've got security vendors making empty promises about how they're going to make your software safe and secure. And all this, you've got this imminent pressure as developers and juxtaposed against this kind of confusion about what to do. So it creates a lot of problems. There's also this thing about a software anti-pattern in software development where third-party apps who want to gain API offerings from a vendor, they're forced to sometimes log in with your credentials, log into that API on the behalf of the user. But there's no guarantee that that third party is going to be safe, is going to safeguard your credentials, or that they're going to promise not to abuse them or anything like that. And this is becoming an increasing problem, especially in the cloud security space. So cloud application security, I'm going to look at this just a sort of sample app. We're going to look at its application evolution through the cloud from the lens of this travel agency business. Transition to the enterprise business over time. It'll focus on this idea, we focus on this idea of identity management. In this particular case, there's 8 enterprise services shown, various levels of client interface and backdoor adapters. You can assume that there's database access involved in all of this. And in simpler times, this might have just looked like an OpenEdge application, typical OpenEdge application, software all sourced from a single vendor. Easy to extend to new or local or remote services, consistent identity across all the services from end to end. That traditional OpenEdge can manage that, right? It can manage identity in the context of your services with only a single client principal application. That client principal can cover identity end to end. It can provide, you probably authenticate only once with your client principal. You probably pass it around throughout your enterprise as a valid token throughout. It provides both authentication and authorization for many people. And it works fine, but only in the context of OpenEdge. So as your travel app begins to scale upward, trying to meet larger demand, you start offering independent services with high availability, perhaps through REST interfaces. Begin distributing services across a range of enterprises. The new services tend to look much less homegrown. They may be multi-vendor. They come from they have service dependencies to different architectures. Your enterprise landscape gets complicated. You might no longer have the luxury of end-to-end enterprise security. There may be real requirements to interact with some of these security architectures that are associated with external sources. So compound this with an emerging trend in which user ID-based security models, these authorization models are starting to narrow. It doesn't scale well for us to be doing identity management, neither for OpenEdge nor for most of our customers. It's not flexible enough in the way it handles security. Who wants to be on the hook to do authorization system maintenance, and authentication system maintenance? You won't do it more safely, more scalable, more online, more 5 nines than any of the authentication providers. They're going to do a better job. They're going to keep up with standards like GDPR. They're going to keep they're going to upgrade to new encryption standards. They're going to keep your identity managed, and having to keep your own identity management system, ahead of the curve is non-trivial. You're going to have to write your own extensions potentially now to these new standards for tokens for the cloud marketplace. And yet, at the same time, identity is critical, right? It's critical to your applications, critical to the consistency of your applications, the integrity of your identity. is sort of a foundation for any of the authorization procedures that are going to come afterwards, or any of the kind of layering you do on top of security, especially in the cloud. So the identity is often, the foundation of all these subsequent security layers. So access to standards. So OpenEdge, our OpenEdge strategy as we go forward is to provide access to standards-based identity tokens, to examine those tokens and secure service environments for them, to enable them to be used as, to call other OpenEdge services or to call through to non-OpenEdge services. OpenEdge is not involved in obtaining or maintaining valid identity tokens. OpenEdge operates totally within the resource provider space. We'll talk more about that. Standards-based identity tokens can be consumed only through REST, web, and static file access transports. As a pure data service, OpenEdge requires clients to pass their identity token through HTTP requests and to handle those HTTP status returns. OpenEdge won't operate in an interactive client login, nor allow clients to handle this directly. Clients adopting these new standards are stateless and can't be supported by sessions. PASOE can try to approximate the relevant token claims and their associated client principal attributes. PASOE token exchange already does most of this. It has the ability to pass identity tokens throughout all your services. The token exchange functionality can accept your standards-based identity token and render it usually as a sealed client principal. It allows your ABL services, your applications, and your database to utilize that identity information just like you were able to handle the client principal before. So if we look at the flow of these steps for this particular application, the way it would look is that first we would download the encryption keys configured to validate an inbound identity connection. And these must not be expired if they're to be accepted. Then we would map the validated identity token to client principal attributes. We then use the multi-tenancy domain access registry to seal that client principal, and we would pass that client principal on to the REST APIs in the HTTP request header. You can use the token to implement role-based URL access controls against the URIs of the REST services. Oops. And if and when ABL service requires access to other non-ABL services, this token can be passed along. The token exchange process is configurable inside of the PASOE Spring security properties files that are available to your web applications. Regardless of the token standard used, client principal token mapping always requires two OpenEdge attributes that must be mapped. The first is user ID, and the second is OpenEdge domain for multi-tenancy. I'm making a distinction here between tokens in general and tokens for these standards in particular. So for all of these properties, it depends on what the original token is and what standard it's trying to, it's requiring or producing. There could be roles that could be mapped to access controls. There could be token expiration. There could be a multiple of OAuth or OIDC fields. There could be a client ID, et cetera. So these can all potentially be mapped within your Spring configuration. Okay, so now we're going to go into the OAuth 2 and discussion a little bit more. This is OAuth 2 and OIDC, OpenID Connect. If we contrast these two, this is a new world of sort of complicated service offerings with a wide service audience. Sharing passwords or giving away third-party, credentials is no longer an option anymore. And, the whole idea of least privilege security best practices just goes out the window with such a notion. So if I own a resource and give you my credentials, how do I stop you from accessing unintended resources? Even if I do stop you, if you have a valid token, you can continue to do so if you want to. If a third party is trusted to protect my identity and someone steals my credentials, what happens then? Now, these are open questions. How do you let your application access data without requiring a password? That's kind of the question. And when we put that question in the context of OAuth 2, we're asking, how do we delegate resources to apps without giving identity away? In the context of OpenID Connect, we're saying, how do we delegate identity-related info to apps without giving away identity or password information, credentials? So here's where the emerging standards of OAuth 2 and OpenID Connect begin to apply. We'll go into the 4 roles that are available, that are required in the OAuth 2 flow. There's the resource owner. And by the way, clients and resource owners are separate roles, which is kind of confusing at the beginning, for me anyway it was. A client is your application. The user is the user who owns a resource. So a resource owner approves someone's access to a resource. That's their job. The client requests that specific access to a resource. The auth provider is the one who grants the token that provides the access to that resource, and then the resource providers themselves provide the access to those resources. So it's not that complicated, and I put together a little demo sort of a demo, for how this OAuth flow works. To explain it, I'll use a hotel room analogy. You start at the end of the access flow and work our way back. The card reader is your hotel room door, is the card reader on your hotel room door, and it's your access provider. The party authorizing your access to the room is the front desk. The client token is your access card. Oh, and by the way, your room is the resource. The client token is your access card, which allows you to gain access to the room. The resource owner is some cynical character who arranges a swamp-like system in which he concedes your room access if you're willing to ransom over enough cash. Who would conceive of such a diabolical scheme? Oh, this guy, probably. So I'm kind of a political junkie, so that was funny to me. Anyway, this is resource delegation flow. This loose standard includes conventional and unconventional use cases that will confuse us, but the flows between these 4 roles always contain essentially the same access goals. And the tokens and resources may or may not be a one-to-many situation. So, for instance, my access card can potentially get me access to many things. OAuth is solving an increasing number of these types of problems for applications in a service-based architecture. I will say that your ID card in most hotels, and they'll ask for identification information, but I will contend that that's sort of an anomaly, a vague anomaly to this resource delegation process. They actually will take your cache and give you an access card. It's just a formality that you're asking for the identity. The point is that in an OAuth flow, you're not gaining access to you're gaining access to a resource without having a particular identity. If you need a use case for that, you can simply look to the cleaning people and say, well, how come they get access to a room? If I own the room and if it's my resource, then they should have to take my token to get into my room. But they don't need to do that because the token's not tied to my identity, right? It's just a token that provides access. So it's good when you think about OAuth 2 flow that you're thinking about it in those terms. Now we're going to look at the OpenID Connect flow. It's simply an identity layer superimposed on top of an OAuth 2 flow. The roles and the flows are essentially the same, but the players are named differently. In OIDC, the end result of the flow is an ID token, whereas the end result of a OAuth 2 flow is an access token. They are different from one another. The difference is dimensions of trust. So the ID token has trusts associated with it, and trust is important for knowing that someone who has a token has an authentic identity, as opposed to in an OAuth 2 flow, you're just looking for, have they been authorized to a particular resource, irrespective of their identity. So let's replace the OAuth 2 flow with an OpenID connect flow. Did that work? No. Okay, so now our resource owner is no longer that guy. It's this other guy. It's our end user. The resource he owns is not Mar-a-Lago Hotel. That was Mar-a-Lago Hotel, by the way, but his own identity. And the client app, i.e. the role that acquires the tokens, is called a relying party. And the authorization server is now the identity server. And the identity server negotiates with some authentication provider who is undefined by the OAuth and OIDC standards, i.e. it's not in the spec. The standard assumes nothing about how some account store holds user information for safekeeping. Does the IDP, the identity provider, actually negotiates that trust between, an authentication server and itself? Do they trust one another? It's a good question, but it's beyond the scope of the standards to ask the question. From the standards perspective, it's an identity token that gets produced, and that secure authentication between the end user and the authentication provider is conditioned by the identity server, whose responsibility is to get that identity token out of that authentication system and back to the relying party. So now the relying party gets this ID card, and the ID card is the resource. And I don't know what you do with your identity in your hotel room, probably nothing. But the analogy's been put together. But in this particular case, I'm saying, I'm sort of drawing this. In the ID case, the example might be that the end user here has an account with a resource, a pizza delivery service. And in a prior consent situation, he told that resource, that pizza company, where his address was. So now he orders his pizza. He doesn't have to give his address information to the pizza owner, because the pizza owner also has access to his address, right, through a resource consent that was made earlier. And so, the application of providing pizza to the end user is built into that knowledge of some identity component of that end user. So if we look at that auth flow, we'll just look at it from a little more detail. This is the OAuth 2 flow. Just keep in mind that superimposed on this could be the idea of getting an identity token through effectively the same flow. This particular OAuth 2 flows, there is one particular OAuth 2 flow called the grant flow. It's the most applicable to working with services, so it's the one that you should use if you're going to provide service access to your users. It's safer than to use another flow that's called the implicit flow. We'll also touch on that. So we start with client registered. If it's the OAuth, if it's the grant flow, then that client is registered to the authorization server, OAuth server, and they want to use a resource. And so the second step is to validate that client. So in the OAuth 2 flow, it authenticates that client. The resource owner's credentials are never shared with the client. And another thing that happens is an HTTP redirect gets sent in advance to the token endpoint, that /token location, with an endpoint to the client, so that when the token is produced, it can be delivered directly to that client without going through a user agent, without going through a browser. So that the advantage, there's security advantages there. The advantage to the simpler implicit flow is that there's fewer round trips, it's more efficient, and there's no intermediate processing. It's also, important to acknowledge that if your client is already an in-browser application, a single-page application of some kind, then that browser is going to get exposed to your token anyway. So there's no particular advantage in that case to use an authorization flow, code flow. Okay, and then regardless of what flow is used, the resource owner must log in and be authenticated through the authorization server. The OAuth, step 4, the OAuth server is responsible for validating a secure authorization and any related flow requirements. If the authorization code flow, if it is that authorization code, the auth code flow, it's called, the client then sends a URL redirect to the token endpoint with the authorization code. At that endpoint, the token endpoint will validate the authorization code, will validate the client that sent that authorization code, and will validate the client's secret. This is versus an implicit flow that just kind of assumes that the authentication was successful if it happens to get a token back from the server. So step 7, if a client successfully acquires an ID token, then the ID tokens are credentials used to access protected resources. The identity access tokens have scope and they have duration. The ID or access tokens grants are enforced by the authorization server and validated by the resource server. ID tokens, ID or access tokens are abstract. They allow for many formats and utilization methods. ID tokens can reduce authentication requirements for resource owners and reduce the authentication demands of PAS-OE as a resource provider. Certain tokens may come also with refresh tokens, which are simply allow you to re-access a resource without having to re-authenticate if a token should expire. The authorization server must authenticate client if the client is included. Actually, I'm going to skip that part. Step 8. The resource server, which is a domain, the domain of the PAS-OE, hosts protected resources, right? It can either accept or reject a resource request after it examines the access token. Gets to decide. But as a side note, especially in the implicit flow, client apps should store that ID token not in the URL itself, because that just provides more exposure. They should copy it into an HTTP authentication header and pass it with the bearer schema tag to minimize exposure. Step 9 and Step 10 are limited in the current environment. The resource server may need to obtain validation information from the authorization server based on the type of access or ID token that's given to it. As it relates to acquiring signature keys, the current PAS-OE environment only allows access to remote keys through what's called the JWT key store. That's embedded in Spring. Otherwise, keys are used for token validation. They're expected to be inside of local key stores of PAS-OE. Various other key acquisition or key validation requirements may exist for your particular token, such as if it was a reference token, also called an anonymous token. These require communication between the resource server and the authorization server, and not currently supported in the product. potentially in the future. Resource servers may also be required to do introspection over a token, which means the resource server goes to the authorization server and asks for additional claim information, or requires the authorization server to do the examination of the token instead of doing it itself. So, and again, these are special, these are not self-contained tokens, and at the moment, OpenEdge is requiring self-contained tokens. So in other words, all your claims and requirements are expected to be embedded in the JWT that it receives. Step 11, upon receiving the access token, the resource provider's job is to validate the signature of the token, which is signed by the authentication provider using the resource provider's secret key. After validation, it has to determine whether the client has the necessary claims, and then it will redirect to protected resources through the service interface. PAS-OE has its own claim requirements, but the list is nominal, and the list of claim validations required by the resource, by the standard itself are also rather minimal. Most of what is required in terms of the list of claims that you will require are whatever your enterprise level decides, right? That's what's important. If everything goes well, then, oops, last step is step 12. Did that work? No, it didn't work. That's odd. Oh, I don't know. Step 12 is a token passes all the requirements configured in Spring Security, and the service request is satisfied, and an HTTP 200 OK is sent to the client as its successful response. So now let's look at OpenEdge token requirements in particular. At the root of these emerging standards is what we refer to as the JWT. It's also known as the JOT. The JOT is a JWT in JWS format is called a JWS, although some people still refer to it as a JOT. It's a JOT also, but it's a signed JOT, which is a JWS. In OAuth 2 and OIDC standards, the JWT cannot exist by itself. It either has to be serialized as a JWS, a signed JOT, or it has to be formatted for a JWE, which is an encrypted token format. We currently do not support the encrypted token format. The reason is because Spring Security 5, which is its latest version, also does not support JWEs, so neither do we. Your header specifies which encryption method is used to sign your JWT. And as you can see from here, the second field is your payload, and it describes it as in this slide as a set of JSON formatted claims. In reality, the JWT standard does not itself require that the payload be even be JSON. It can be anything you want as long as it's base URL, 64 URL encoded. So our OE perspective on JWTs is, in general, is pick your poison, right? Whatever you want to pass in terms of JWT and whatever you want to configure in Spring for PAS-OE, as long as you render the parts of the claim expectations we have in particular and your own claim expectations, then based on your Spring configuration, then OpenEdge will identify whatever you send as having valid ID token characteristics, and it will accept it, and it will render a sealed client principal as a result. You can consider passing it around at that point through your backend services or to non-OpenEdge services. PAS-OE currently supports two JWS encodings, HMAC and RSA. HMAC is more for development. You probably want to go to RSA for your deployments. In the case of HMAC, you have the same key signing as well as verifying. In RSA, you have the authorization server encrypting with the private key, and then the resource provider decrypting with the public key. And this view is, by the way, kind of what you'd see if you were in JWT.io website and you loaded in a client principal that was, a JWT that was base 64 URL encoded. It would actually render the JSON for that object. So it's a good website to use. As mentioned, an ID token, so OIDC token, ID token, or an access token from OAuth 2 are JWTs in either JWS or JWE form. There is an additional standard called JWK, which again we only provide through that JWT Java key store that Spring provides internally. We don't conform to that standard on necessarily on any additional level at this time. And so those are all the standards. There's one other standard called the JWA, which talks about all the different ways you can encrypt a token. And, but again, the only ones we support today are HSA and RSA. So recall that the OAuth 2 flow discussion earlier that, before the step 12 can be performed, the resource provider must validate the token signature and validate that your enterprise ultimately will decide that what claims are required by the clients who exchange tokens for the service. Your enterprise does this through Spring OAuth 2 configuration inside of your PAS-OE web servers. You can pick as many fields that map to Spring or for OAuth 2 as you'd like. OAuth 2 spec itself reserves very few of its own. OpenEdge does require that claims have the following. The token must have an ID claim, so there must be a user's login ID mapped to what's called the subject, SUB. That is the last slide. And then there's also an audience claim that must be provided from your client, and then an expiration claim that's required in order to ensure that your token has not expired. Some additional claims can be mapped. The important one in this case is scope. And so what can happen is I can map a particular claim. In this case, it's typically scope, and I can map it to roles inside of my client principal. At that point, if I have those, I can go to the OE/ABL security JWT CSV in my web application, and I can set up role designations for access to particular web services using the roles that came from my token that are now in my client principal and regulating access to those services. So that is the presentation. There is security and compliance risks with cloud application deployments. It's probably a little more cloud-based than this discussion was. The important thing in this discussion was simply that your cloud applications in the modern service-oriented world are suffering because identity consistency across end-to-end is difficult. And these particular protocols can provide some relief in that respect. So thank you. Questions? Or I can talk afterwards if you'd like to.